Hello and welcome to Elektor Engineering Insights, the show that puts your engineering challenges to the industry's experts. I'm your host, Stuart Cording, the electronics reporter. Embedded World is a trade show for those working in and around embedded systems, but due to corona restrictions, the event has moved around over the last few years. But this year it was back to its usual slot. Spread across 6 of the halls in Nuremberg's exhibition centre, it was home to microcontroller vendors, software developers, component distributors and startups. Accompanying the event was the conference programme, providing technical insights and discussion on industry issues and trends. I spent 2 days walking the trade show floor to learn what innovations are under development and how electronics in the automotive industry are changing, and discovering some of the players around RISC-V. And this is what I saw. Hi Brian, great to see you here at Embedded World 2023. Now, what's been happening at Qorvo? You've got the power application controllers, the PAC system in place for quite a while now, focused on motor control.
Yeah.
And I see you've started to branch out into another aspect of, which is very important to motor controlled applications. So what's new?
Yeah, we're super excited here at Embedded World 2023. We're announcing a brand new product family for us at Qorvo. As you said, for the last 10 years, we've been really investing heavily in that trend for brushless DC motors. But in all those applications that are moving to brushless DC, you see battery power, requirements that are all through there. So, our customers are asking us, hey, you're experts on the motor control side and intelligent motor control, why not help us with the intelligent battery management? So what we've announced is this new product called the PAC 22140 and the PAC 25140. It's the industry's first intelligent, fully integrated 10-cell to 20-cell battery management part. Pairs up perfectly with our motor control solution, so now we can really be that complete solution provider for anybody doing a motor control application that's battery powered.
So in that, in the motor control application, you've got a sort of split architecture. You've got a digital side and an analog side, and that analog side is dedicated to motors. How does the PAC 20000 series look? Is it similar?
Yeah, so I think in a lot of these applications, you need that intelligent digital core, but then you also need that high performance, high voltage analog capability as well to do these power management or motor control and battery management type applications. So on the digital side, we use a industry standard ARM Cortex M0 or M4F. We offer that both on the motor control side as well as on the battery management products. But then on the analog side, it's critical in the motor control front that you have motor drivers that can range from 40 volts all the way up to 600 volts. So that's not going to be in a digital process, that's going to be in an analog process to hit that high voltage. And then same thing on the battery powered side, you see battery packs now moving from 40 volts to 60 volts to even 80 volt battery packs. And so with this new family of battery management solutions, we've actually developed the analog portion of that in a 160 volt process node. So it gives tons of headroom over an 80 volt battery pack, for example. So yeah, having that digital intelligence is key, but then having that high voltage analog for the power management side, and we're trying to bring both pieces of the puzzle to customers. So.
Now, a lot of different applications are going electric. We're moving away from gas or ICE-powered equipment like lawnmowers and even like small diggers and things like that. Also in the small hand tool space, we're seeing a lot of things moving away from cable to battery-powered. What sort of application spaces are you targeting with this battery management system? Yeah,
so this, really you see a broad range of industrial-type products, whether it's power tools or e-mobility, but even kind of getting away from just motor control, there's energy storage type applications and stuff too that have larger battery packs in it. So I would say our focus is really on broad industrial type applications. And like I said, we've been playing in that area on the motor control side for many years in a broad range of applications, like I said, from tools to e-mobility. And we expect that that's only going to kind of proliferate to many more applications over time.
Now you said on the digital side you've got a microcontroller in there, but how do engineers and engineering teams get started? Is there like some fixed software and that's what you use and they've got some knobs that they can tune to their application, or is it fully programmable?
Well, you know, it's a number of different things, but it is fully programmable, both on the motor and the battery management side. And the nice thing is, since it's a common digital core between both platforms, once customers build the tool or get the tool set up and everything, all the example code and everything, they really get used to one common core they can use across both the motor control and the battery management side. At the same time, we're building ecosystems with development kits, you know, GUIs that they can configure the device, so we give them a lot of great starting points so that the out-of-the-box experience is nice and easy to get started. But then when they want to add their own IP, once again, fully programmable architecture, that they, you know, they can really differentiate their solution however they feel fit as well.
So we've got a new product here on the Embedded World Trade Fair stand. Is this then immediately available for people to get started, or when's it sort of going to be available for integration in new designs?
So we're already in production on our M0 based platform, so they can go place orders today for evaluation kits and samples. On our M4F platform, we're sampling that as well today, and we'll be in production in April, so we're very soon. So it's all readily available, development kits, samples, data sheets, all the documentation and collateral. So, you know, we're excited to help customers get started.
Fantastic. Well, thanks ever so much for taking us through the design today and the new product. Wish you all the success for it, and we look forward to seeing what comes up next year.
Thanks a lot. Thanks for the time. Appreciate it.
So, hi Johan, great to see you and the Embeetle IDE team here again at Embedded World 2023. We chatted last year and we went through the development environment. It looked really impressive, very clean. I hear you've been very busy in the meantime, adding a lot of new features. So what's been added?
Yes, welcome back, of course. Great that you're asking. We have really added a lot. Since last year, we've added a debugger. So you can do with the graphical user interface, you can debug, step through the code, the breakpoints, everything is there. We have also added analysis, well, we already had analysis of C++ files. Yeah. We also analyze assembly files, linker scripts, binary files. And analysis means that you can actually see the symbols that are defined or used there. You can see the cross references, click on the symbol in one file, go to the other. Everything works. It's something that very few general purpose IDEs offer, of course.
Yes,
they're not interested in looking at assembly code.
Exactly. And so how does it also look in terms of microcontrollers that are supported by the environment? Have you been expanding the support there as well?
We've been expanding, but only a few microcontrollers, but that is actually coming. I cannot share all the news we have yet, because the negotiations are still ongoing. I can reveal that we are talking to GigaDevice. We made a press release a few years ago already. Okay. We're getting very close there to the next step.
Super.
And for other deals, they will come. Yeah. I really believe that this year will be the year of the breakthrough of Embeetle.
Fantastic. Now, the development environment itself, has that changed at all in the way it looks and how it's used? And what sort of feedback are you getting about the environment?
We have done some redesigns, because before we sometimes got this feedback, it looks a bit old-fashioned. Okay. It's really looking quite modern now. It has I think the dark theme was already there last year. The icons have been redesigned, but more than that, we've really been working on the stability, on making it really robust. Feedback we're getting, this is really simple to use. It's an enormous difference with a traditional IDE to get started. I think our message is beginning to get across. People are beginning to understand it.
And are you managing to build a community around Embeetle as well, and get sort of like people interaction with each other and helping each other out?
We have experienced engineers just contacting us, asking, please, can we help? Look, I would like to help you with testing. Look, I would like to add something. Can I implement for you? They're not asking any money for this even. Wow. So people are really enthusiastic when they see this.
That sort of reflects our community, doesn't it? Everyone wants to help out, get involved.
Yes, exactly. It's something, it's amazing. I mean, we are a commercial company, but still we get these volunteers who want to help us.
Yeah. Fantastic. And how does it also look with debug hardware? What sort of debug hardware do you support?
We have a really big set of programmers, debug probes that we support. And of course, not all of them are compatible with all microcontrollers. That we cannot change. But there's a wide selection in Embeetle. They are all documented on the website, how to use them, what are the limitations, what are the benefits. So not much has changed since last year there, but it's still essentially the same.
And in terms of processor cores, what sort of microcontroller cores are supported?
Okay, we are mostly targeting the low-end microcontrollers. It's where Embeetle stands out the most. If you have, you want to program a Raspberry Pi where you have Linux running and you can run the compiler on the Raspberry Pi, there's no real need for something like Embeetle. But if you want to run a 10-cent microcontroller somewhere from China, and the IDE that they support is Eclipse-based with some plugin that sometimes works and sometimes doesn't, then you want Embeetle support. Okay.
So that means mostly ARM, or is there support for RISC-V type
there
cores?
There is RISC-V, there is ARM, we have some big micros with Arduino, there's a quite wide range of so Cortex, all kind of ARM cores. Yes, they're all there.
Well, thanks ever so much for giving us the update. It's great to see you here again and to see that the whole project is developing further. And have a great show.
Thank you so much. It's so great to see you here again, Stuart.
So, hi Robert, great to see you here at the ARM stand at Embedded World 2023. Now, ARM is obviously very well known as the supplier of IP for a large majority of the microcontrollers that go into automotive space. And that's an area that you personally have been exploring to see, what's the future of automotive going to look like. So, what are you seeing?
So what we're seeing now is the software-defined vehicle is being seen as the future of automotive. So no longer, your vehicle's going to be defined by the software functions that are in it. Those software functions are going to be updatable, upgradable, when you as a consumer of a vehicle have actually got it. So we're seeing that happening now, but it's really changing the way people need to do the development of vehicles. There's a lot more software is going to be involved, and so you need to have a different way of actually doing software development and also software deployment to the sort of traditional ways of doing it. And so that's what we see as the future of automotive right now.
Now, just to explain, sort of today, the way software for automotive is designed, it's developed, popped into a box, that box goes into the car, and then we work on the next project, don't we? It's never updated, but are there parallels in other industries and other market segments that we can look to say how we can sort of make this updatable software possible?
Yeah, and that's what we've really been looking at. So, so you're right, traditionally you'd kind of build this thing called an ECU, electronic control unit, and the software that would go with it would kind of go there, and if you needed to update it, you'd go to the dealership and they'd do some sort of update.
But that's rare, isn't it? It's not like we don't go for a feature update, we go because a problem's been found.
No, absolutely. So what we're seeing now is the opportunity to really kind of treat the car a bit like you treat your cell phone or your computer, which gets better over time. Every time I get an update to my operating system on my phone, it's great. It's like I've got a new phone. The car should be the same. It shouldn't be that when the car leaves the dealership, it doesn't get better, it should get better. And so I think that's going to really kind of change the way we kind of do our development and also continuously update. So there is a parallel in the world of cloud development called cloud native. And so what they do there is you have this continuous development and deployment in the cloud for a cloud instance. So you're writing code that's going to run in the cloud. What we're looking at is whether you can use some of those methodologies, standards, tools, techniques to develop in the cloud but then deploy to a vehicle. What that allows you to do is actually start your development early. So you don't have to have your ECU there. You're going to do development in the cloud, and you know that you're going to deploy to some system sometime in the future, but you can actually start your development early. Also, once it's been deployed and your vehicle's out there, you can actually continuously update it. And that's what we see with the being able to use some of the stuff that's come from the cloud and actually use it for the vehicle. So we took it a step further, and we basically formed this initiative called SOAFEE. It stands for Scalable Open Architecture for the Embedded Edge, and is really about using techniques that have come from some other environments like the cloud, but applying them to embedded and automotive and software-defined vehicles, the first one. So we actually have a demo of SOAFEE here, and this is really sort of showing how you can take these software-defined workloads, develop them in the cloud, and then deploy them. And we're using techniques such as orchestrators and containers that are used in the cloud, but we're actually bringing them down into the vehicle.
Now, one of the key differences that everyone's going to say is, yeah, but the cloud, that's not functionally safe, that's not real time. Those are the big things in automotive. It's got to be safe, it's got to be real time.
Yeah.
So what changes or adaptations to this methodology are you needing to make?
Well, and so that's what SOAFEE is all about. But you've actually hit it completely on the nail on the head there. So you're right, the cloud doesn't really know anything about real time, it doesn't know anything about safety. Whereas the vehicle is all about having functionally safe software and stuff like that. So what we're doing as SOAFEE is we're looking at the existing standards that are used in cloud, but actually adapting them so that they can be used for functionally safe or real-time systems. And understanding that the architecture of a vehicle is a lot of heterogeneous compute. You know, people are saying the car's going to be a data center on wheels. Sure, but it's going to also need to have these functionally safe and real-time components. And that's what SOAFEE, the sort of industry organization that SOAFEE is really looking at that, and as to how can we bring this functionality into these existing standards. And so when we formed SOAFEE, we actually wanted to have different companies and organizations across the whole automotive and software space. And so if you go to soafee.io, which is our website, you'll see who the founding members are, OEMs and tier ones, software companies, really trying to everyone to come together. And now what we're doing is we're basically going into the implementation phase. And this is a good example where we actually have a demonstration of a SOAFEE-based system for automotive. It's actually running part of an autonomous stack.
Now, when we look at the future of the software-defined vehicle, one of the architectures that's being proposed is the zonal architecture.
Right.
That primarily sees like a massive, powerful, high-performance computer at the center, and then sort of ECUs distributed around that, all of varying sizes, but maybe functionality spread across ECUs or multiple functionalities in an ECU. Does SOAFEE have a limit? Is this really targeting the highest end of this, or could it also extend right into those smaller boxes?
So it depends whether those boxes are really software defined or not. So you're absolutely right that we're moving through a phase right now where we have these different domain controllers, which are still kind of quite big compute, but they're on a specific domain, like ADAS or IVI or whatever. When we get to this sort of central compute plus zonal architecture, that's where it gets interesting, because that central compute is going to be running different software functions, different domains almost, and then connecting via high-speed networking to the different ECUs or the zones that will be working with those ECUs. But the idea is anything that's software defined in the vehicle, you should be able to take advantage of the SOAFEE architecture to actually develop and deploy.
Well, Robert, thank you ever so much for taking us through SOAFEE. It's very interesting, and I think it's a very exciting initiative, and really looking forward to seeing how it plays out in the coming years.
Thank you.
So, hi Sonu, it's great to see you here at Embedded World 2023. We're here at the Logic Fruit Technologies stand. Now, what I wanted to start with is to understand what's the area of expertise and services that you provide to your customers.
Yeah, so hi Stuart. We are primarily we are working in the embedded field. We are a product engineering service firm. We are generally a R&D organization. We are doing the consultancy services as well. Our key focus is on FPGA development. Around that we do the hardware and software bring up around those concepts and conceptualization, and we are working on high-speed compute embedded solution as well, like cutting-edge technologies like Gen 6 and CXL technologies as well.
Now, FPGAs, there's obviously lots and lots of choice on the market. Are there any particular manufacturers that you are specializing in?
So we are a Golden Alliance partners with Xilinx. Primarily, we are dealing on their hardware, FPGAs.
Now, there are also lots of different areas where FPGAs are deployed, obviously normally more complex applications.
Yeah.
What sort of types of application spaces do you commonly get involved with?
So we work on various domains, like aerospace and defense is one of our key areas. Apart from that, we work on test and measurement as well. Apart from that, we are working in telecommunications as well. And the recent in AI and ML also we are working.
Now, telecoms is obviously another area that is lots of change, lots going on, and 5G and software-defined radio is a big thing. Is that an area where you can provide support and expertise?
Yeah, correctly. So we do have our own software-defined radios IPs with us. That is the in-house developed IPs. Apart from that, we do have some radio solutions as well, the radio model, which we have developed for one of our customers over in India, that can support a link up to 40 kilometers.
Now, when a customer is interested in getting support in an FPGA project development, how is the best way to get started with you? What do you need from them and how does the project develop?
Since we are a turnkey solution provider, what we need is a concept from the customer. What he's thinking, what's the bring up, and we will do all those turnkey solutions with them, and they will discuss and we will bring that solution to the real world. That's what we are doing.
Now, obviously, you're focusing on FPGA design, but the boards typically require some analog, there's memory that goes around there, maybe some additional microcontrollers. Is that an area that you provide support for as well?
Yeah, we do provide support for the heterogeneous system also. We have various solutions in past with which we have worked. There are heterogeneous systems which we have done the solutions for one of our key customers like Keysight as well.
Now, FPGA design is a lot about IP, developing those blocks to make sure the functions as expected. If somebody's working with you, is that IP belong to them, or are there co-ownership models? How does that work?
So it's totally depend upon with the interaction with the customer. It can be co-owned, or we are having our own IPs, GSD serial IPs we have, A-Ring IPs we have in-house developed. So that can be used for the customer application as well. But yeah, at the end of the day, it's depend upon the customers and their requirement.
Now, one of the most important things when you're considering a service provider to help you with a project is to understand how big the team is and the experience you have. So when was Logic Fruit founded and how many people do you have on your team?
So we started our business in 2009 over in India. We started from there. Then we have grown up to a team of 275 engineers based out in location in India and US as well.
And if somebody is looking to get some support and some guidance and help on their design, what's the best way to find you and get in contact?
You can definitely contact me. Apart from that, we have a website, thelogictechnologies.com. You can easily get in touch with us. There is a web form over there. You can put your details, your requirement, and we will contact you within 4 hours.
Fantastic. Well, thank you ever so much for taking the time to give us some insight as to what Logic Fruit Technologies is doing. We wish you a successful show here at Embedded World 2023 and look forward to seeing your next projects.
Thank you, definitely.
Hi Flavia, it's lovely to see you here at Embedded World 2023. You're part of the Oxid OS team. Tell us what's so special about this real-time operating system and why it's different from others.
Hi Stuart, it's very nice to meet you in person. I've been following you on Twitter for quite some time, so it's nice to see you in person. What's so special about Oxid OS is the fact that we're this kind of environment for software development for automotive ECUs. And what's special about us is that we took the problems that are right now in this automotive industry, which are problems with the safety and the very lengthy delivery delays, longer development cycles, and the difficulties in changing machine components. And we're building this ecosystem, a Rust-based secure operating system, and development tools for medium-sized microcontrollers in automotive ECUs.
So Oxid OS is a real-time operating system using Rust, which is a bit different, isn't it? Because normally most people develop in C, C++ in the automotive industry.
Exactly, exactly. So the problem with the current technologies that are being used right now in the automotive industry is that the technologies are outdated And there are many additional tools that are being used to enforce a high level of security, further complicating the whole scenario. So we're taking Rust to build this operating system and development tools for a faster time to market, lower development costs, time reduction regarding development and certification, and of course a lot of security issues that are being gone.
Now, of course, Rust is a new language, relatively new language on the scene, and not every microcontroller manufacturer supports it with a compiler. So which microcontrollers are currently supported, and do you have an Oxid port for?
Well, right now we're working with some leading industry partners, some proof of concepts. We kind of are flexible in this area, so we can support any kind of microcontroller that wants to work with us on this. And we also have a demonstrator at the ST microelectronics stand. So that's one kind of board that we support, and ECUs.
Now, your operating system solution is not just a code base which you can download and use. You actually have a complete ecosystem for development. Take us through the development process that you have.
Yeah, so it's an entire ecosystem. So it's an operating system and also development tools. We have this demonstrator here, how to build an ECU in under 60 minutes. So to better demonstrate it, you take the board out of this, you connect it to your laptop, and then you log in onto our platform. You create a new project. You select the kind of board that you have here, the kind of ECU and the drivers, and then you're going to start the project, and a VS Code instance will be launched, and you can start programming your ECU right away, so under 60 minutes.
Now, you're here at the startup area of Embedded World, which is here to sort of promote young organizations that are making their first steps into this embedded community. Tell us a little bit more about the team behind OxidOS.
Oh, our team it's wonderful, actually. We're a strong multidisciplinary team with many years of experience in software engineering, automotive engineering. We have 4 PhDs, I think, or 5. I lost the count. We're 12 people right now in the startup, and we're growing. And we hope that we're going to continue growing. Yeah, it's been a lovely journey. Our team is excited to be here. We've been here at the Embedded World with other projects that we have, but OxidOS was born 2 years ago, and we're hoping to be at Embedded World again and again with it.
Now, Rust is a very popular, interesting, exciting language. It's probably the newest thing we've had as a programming language for microcontrollers. How can people get started with OxidOS? What's the best way to get in touch with you, and what can they do to get started?
So I think an important part to mention here is that our co-founders are actually part of the Rust Foundation. So our CEO, Alexandru Radovic, is one of the first people that contributed and started programming in Rust, and he is in love with Rust. You can find us at EuroRust, the Rust Foundation, and so on. But if you want to get started with OxidOS, just go to our website, oxidos.io, and you can write us there, and we're going to get in touch with you because we're a B2B company. So right now we're working with larger companies to on proof of concepts for this kind of environment for automotive industry.
Well, thank you for that fantastic update about the project. I think it's absolutely fascinating, and I'm really excited to see how it develops. Flavia, it was lovely to see you.
Thank you so much. It's really nice to meet you in person and not just tweeting.
Hi Blair, it's great to see you here and join us at the Elektor stand. Now, we've been talking in the past about Neuton.ai, and thanks for coming by to talk to us today. Just give us a bit of an introduction. What is Neuton.ai and what's your specialism?
All right. Well, thanks for having me. It's a pleasure to have an opportunity to join you here. When it comes to Neuton.ai, I always like to say we're probably the best kept secret on the market right now, and we're trying to make an effort to solve that at the moment. But really, what we're doing at Neuton.ai is that we're really focused on really enabling everyone to be able to bring intelligence literally to any device. That's really our objective. And we believe that we've done a great job in doing this, and it's something that we're very excited about.
So what we're talking about here is machine learning, or more generally spoken about artificial intelligence, and getting that into microcontrollers to really enhance the functionality that they can offer. What sort of applications are you seeing being developed with machine learning models built into them? Yeah,
absolutely. So that's one of the things that, you know, when you begin to talk about machine learning, sometimes you say, okay, what is it? How can I apply it? And that's why I always like to say, hey, we really want to bring intelligence. We really want to make things smarter. We really want to make everyone's life just a bit easier. And we've seen a tremendous amount of activity in a number of different areas, whether it's being able to do anomaly detection, let's say fault prevention as an example, to be able to step in before an accident really occurs. In addition to that, where we're doing some amazing things as it relates to activity recognition, especially when you begin to talk about, let's say, smart home. And then lastly, we're also very excited about some of the things that we're doing from an audio perspective as well. So on the security side, whether it's gunshot recognition, glass break detection, or sound event detection, this is something that we're really excited about at the moment.
Now, machine learning is a topic that we've looked at through Elektor many times. It's quite complicated at the basic level to try and develop the models and train things, but platforms like yours really make it a lot easier. What's the development flow? How do people start with an idea that I can implement in machine learning and then push it through your platform to get something they can deploy in a microcontroller? Yeah, I think you really kind of touched on really the heart of what really got us to where we are today, when we began to talk about really enabling and bringing intelligence or machine learning literally to everyone. And one of the ways that we accomplish this is, of course, you know, we not only have automation, but it's a completely zero code platform. So at no point throughout the entire process do you need to apply any coding or anything like that. The only thing that you really need is your data. Of course, you know, data is king, content is king, so that's obviously very important. And some of the tried and true, let's say, statements we've heard before, you know, junk in, junk out, still applies. But that's really, for all intents and purposes, that's all our customers really need, is their data. And as long as they have their data, they're really able to take advantage of our platform. We automate all of the process as it relates to uploading their data, let's say, producing the model. And then once the model is produced, one of the things that we're really, really proud of is that we're able to produce these models in one iteration, and they're always device agnostic. So it really has allowed for us to kind of really spread our, you know, the availability of intelligence irrespective of which device that you're using today. Now, obviously, the engineers developing these embedded systems are very knowledgeable about the application, but sometimes it's a challenge to go through that model creation process. There's a lot of statistics, a lot of analysis. What happens when they're using your platform and they get stuck? Is there some help available? Yeah, and this is another area, right? So it's really a combination of two things. You still need to understand and be a domain expert in the area that you're looking to produce a model. There's no way around that, especially if you're embarking on a journey where you're going to implement that model into production, which is everybody's goal, right? And one of the things that we do is we do couple our platform with services. So we enable our customers to really kind of go through that entire life cycle. And any point along the way where they may need assistance, we're right there. So we enable all of our customers to literally go from A to Z, from data gathering all the way up to embedded into your specific device, and then of course into production. Now, it's lovely that you're device agnostic, but as an engineer myself, sometimes we just like to make sure we're using a microcontroller that someone else has already tried it on. Yeah. So which microcontroller manufacturers have deployed or shown demos that are based on a Neuton AI model that's been created? Yeah, well, we've had the opportunity to work with a number of different vendors that are out there, and we do optimize all of our models for such vendors. Of course, our model natively comes
out, and we have the ability, as an example, to work with an ST Micro, to work with the Silicon Labs, to work with the microchip. I mean, the list just goes on and on and on. And even today, or excuse me, tomorrow, we'll have the opportunity to really showcase a couple of different real live production use cases where we've partnered with some of the vendors that I've just mentioned in order to bring that intelligence to life on these devices.
Now there's lots of competition, obviously machine learning is a huge topic and it's something that comes up at every show that we go and visit. And there's lots of different platforms and solutions available. How would you say Neuton AI differentiates itself from the alternatives that are available?
Yeah, I always like to say we have a lot of frenemies out there, right? So
that's good.
But really, you know, one of the things that's important is really to be able to see, you know, the market of tiny ML continue to grow is really beneficial for everyone, right? And so, as you mentioned, there's a number of different, you know, peers that are out there that do similar things just like we do, and we encourage everyone to, you know, find the right tool that works best for you. For us, we're really, really focused on being able to produce a model with the smallest footprint. Not only from a physical perspective, but also being able to consume the least amount of energy as well. Right. And this is one of the areas that we've really, really excelled out lately, where we've had the ability to produce models that are less than 3 kilobytes in size, and also be able to embed those models, let's say directly on a sensor and not necessarily on an MCU. So being able to produce models that are extremely compact and embed those models in the smallest devices that the market is bringing to bear is an area where we're really, really excelling right now.
So having understood some of the background to Neuton AI, if someone's interested in looking at how they can get started, what should they do? Where do they need to go?
All right, so you can always, of course, go to Neuton.ai. That's always a great place to start. And you know, our platform is designed to be a self-service platform. And our platform is accessible to anyone for free. So certainly if you have the opportunity, go to Neuton.ai, get started for free. And once you begin to use our platform, we make available data scientists, data engineers, embedded engineers, even by using our free platform so that we can help enable you to be successful. So we always couple services with our platform, really enabling everyone to achieve some of the goals that they're going after.
Well, thanks ever so much for dropping by today, Blair. It's really nice to meet you at last, because we've tried this a couple of times.
Absolutely.
Yeah, and we wish you all the best with the conference here. Daniel, it's lovely to see you here again on the Silicon Labs stand at Embedded World 2023. We caught up with you last year to see the developments that were going on, especially lots of wireless on the stand last year. It looks very similar this year, and I heard you've also got some new Bluetooth devices which have just come on, which are really small.
That's right, Stuart. Thanks for having me back here. And yeah, wireless is our lives. So that's really what we're known for in Embedded. And yes, our latest product's the G27. It is the world's smallest, you know, Matter Bluetooth product.
Wow.
And so it has a lot of wireless capabilities inside of it, and it especially supports lower battery voltages from battery chemistries like silver nitride batteries, which are very popular in medical devices. Okay. So it's small, it can take in many different kinds of batteries, and it has all the memory that we need for the latest standards.
And I understand that the chip is so small you could integrate it into a tooth, for example.
That's right.
Talking super tiny.
One of our customers is putting it on the back of the molars for a saliva detector, because you can detect all kinds of things from the body chemistry about what's going on in there. So it's kind of a cool application.
So in the space of Bluetooth as well, are you seeing lots of new applications in the Bluetooth space? In medical, for example, is it gaining traction there?
Yeah, so part of the pandemic, a lot of medical care shifted into the home.
Right.
And that kind of accelerated 5 to 10 years of what would have happened in the medical industry otherwise. They're very slow moving most days.
Yeah, exactly.
So they're seeing a lot more technology go through the phone, really, that application on a phone. So blood glucose meters is a big one that's about to go. And anything else the doctors can get data off these devices. They finally trust the communication, they trust the encryption, now they're ready to pull that data in and make decisions with it.
Yep.
Now, one of the other big themes of Embedded World this year is IoT again. So we've had it for a long time. You know,
Yes.
we've had like a decade of IoT in discussions and billions of devices and things. But I think one of the big challenges we've seen is interoperability, and Matter is being spoken about everywhere. Can you explain for us what's Matter supposed to do for us as an industry delivering IoT products, and what does it do for the consumer who are sort of tearing their hair out trying to build home automation systems?
Great question. Yeah, and Matter is a very big deal. It solves a lot of interoperability challenges at the layer of software that the cloud companies play in.
Yeah.
And so for a long time, they've tried to go down all the way to the physical layer. They just don't need to go down there. So Matter runs on existing wireless technologies like Wi-Fi and Thread and 15.4.
Yeah.
So it brings it up to a layer that they can interoperate with each other with, and that's very important because now you can buy devices in one ecosystem, maybe Apple, and deploy them in another ecosystem, maybe like a Google ecosystem.
Yeah.
So that's a big deal. You know, we've been held back for a long time because of interoperability, not because the technology wasn't there.
Yeah.
For the consumer, this obviously makes the experience of creating these networks within their homes, it's a lot of DIY, right? It's more doable now. And another benefit that they may not realize, it's much more secure. So these devices have to authenticate themselves onto these networks in a much more controlled way than anything before. And so there's device attestation certificates, there's all kinds of things built into the standard to make this go.
That's a very good point about security. Security's sort of been a bit of an afterthought. Sometimes it's a bit sort of obscurity rather than security. So what are your customers saying to you about the security aspect, and what are they expecting from you as a silicon provider and a software provider in order to make sure that is really robust?
Really good question. So IoT has kind of moved for most industries away from proof of concept into wide deployment. And their businesses and their business models are now dependent on the data, both directions, pulling sensor data out, but also putting new data, whether it's a software update, a security patch, or just changing the device for the user. And as they do that, the kind of proof of concepts are moving kind of from, well, we're transitioning from IT into OT.
Mm-hmm.
Yeah. You know, IT with my computer, companies understand how to manage my computing device. They have to do the same thing for their rest of their things in their networks now too.
Yeah.
And so a CIO is not going to let anything on their network unless they know what it is and they can trust it.
Yeah.
Companies aren't going to base their new business models that they're now thriving on with all this data unless they know it's encrypted and they can trust it. So security has moved from an afterthought to a forethought at this point, and I'm very excited to see that. We've been investing in this for a very long time.
So how does sort of Matter support that forethought approach?
Well, the spec was built, you know, with a lot more security into it. And so a lot of the standards that were built maybe before in the 2000s time frame were more concerned with making these things actually connect to each other and talk. Yeah, so the way Matter really has a device has to be able to prove it is what it is. And that means certificates, hardware roots of trust that other ecosystems don't mandate. And so because this goes interoperable across lots of ecosystems, they have to push it very deep into the standard. A lot of kind of walled garden ecosystems can solve the security in other ways.
Yeah.
So they push it all the way down to the chip suppliers and the secure supply chains behind them for injection of these keys and these certificates.
Yeah.
So it's mandated, that's why.
So in terms of the security as well, does the security stop with the data communication between node and cloud, or does it go so far when we're thinking about the OT aspect of it, actually protecting the nodes themselves so that the code and data can't be extracted from the microcontroller?
It's both. I mean, so, you know, the device needs to be able to prove it is what it is so it can talk to the cloud.
Yeah.
The cloud needs to know it's talking to the right device.
Yeah.
So there's just, number one, you have to authenticate that. But the devices themselves have a lot of critical data. Whether it's collecting sensor data, very sensitive, private, like my body or whatever it is, or may have valuable data like network keys that maybe allow you to daisy chain into an attack into the cloud. You know, you've got to protect the integrity of that data over its lifetime, and governments are starting to mandate this stuff too as well.
Yeah.
So we think about it as physical and remote attacks. And so it's a little bit different on how you solve for these things, but we have pretty good solutions, and yes, our customers are expecting it from their silicon providers because they know now they can't do this at the gateway level. That's what they thought for a long time.
Right.
It has to be in the node, and they have to do it in hardware.
Yeah.
There has to be something in that device that's not software, so a hardware root of trust of sorts, to be able to prove all of these things.
Yeah. Now, we were talking last night at the IoT Stars event. There's a group of people who sort of in the IoT world, and they're saying like we've been doing IoT for 10 years now, and sort of like the billions of devices that were projected haven't appeared. Where do you see us on the IoT journey? Are we sort of somewhere in the middle, or is it petering out, or is there still room for growth?
I think there's a lot of room for growth. I mean, we do have billions of devices today. I know because we're shipping on the order of 1 billion devices, just our company.
Right.
But it's still got a long way to go.
Yeah.
I mean, multiple industries are now adopting this in transportation, in retail, in security, in core industrials, factory automation. It's just kind of starting to spread everywhere.
Yeah.
You know, for a long time it was proof of concepts within companies. Now they're saying, okay, we know how to use this stuff. And it wasn't just building the device. They had to build a cloud behind it.
Yeah.
They had to figure out how to interact with a mobile phone in their network. So now they've kind of figured all this stuff out, and they're starting to deploy it en masse.
Super. Well, thanks ever so much for the great update. We wish you all the best with the new Bluetooth device. It sounds very exciting.
Yes.
And have a great show.
Thank you.
This episode is sponsored by Elektor. If you like electronics, you'll love the articles, projects and insights you can access as an Elektor member. Our global design community has hundreds of thousands of active members and more than 1,000 contributing experts. You can go traditional and get our magazine delivered to your door, or go digital only and read online. Either way, you get access to years of information and projects, as well as our active community. Follow the link below to sign up today.
Hi there, Trina. Lovely to see you here at Embedded World 2023. We're here at the Imagination stand looking at some of the fantastic graphics capabilities that are coming out of the IP you develop. Tell us a little bit more about the GPU IP that you offer your customers and where it is that they're using it.
Yeah, hi, nice to see you again. So on the booth today we're showing quite a wide range of GPU solutions that we have. So a focus area for the GPU is mobile, consumer, and mostly what we're showing here is automotive, and looking at where our GPUs help to bring this kind of like interactive, smooth movement into all sorts of places in the automotive, whether it's from the cockpit and your driving experience to your passengers' entertainment experience. But we have a really wide range of functionality and performance points to meet a whole lot of different needs. We're all going right the way up into the data center space as well. We're seeing a lot of success and seeing the different ways that the data center needs are changing, brought on by cloud gaming and elements like that that are needing GPU requirements to change, so we can cover the full space and the full range of GPU needs.
So with the scalability of the GPUs, obviously you've got highest performance right down to low performance. Are your customers looking to put all of those in for graphics purposes, or are they also leveraging the capabilities of GPUs for their mathematical capabilities?
Yeah, definitely. We're seeing that combination going of, yes, definitely graphics is still probably the prime reason for using a GPU, but I think seeing those kind of AI type functionality and those compute functionality, especially as you start to move up to the higher performance in the automotive space, with the automotive space moving more to autonomy, there's more compute requirements. So people are seeing their GPU as a really flexible piece of IP that they can use to fit a variety of use cases and functionality for them.
Now, of course, in the automotive space, we're seeing a huge amount of innovation. The way the electronics in automobiles is going to appear in the next few years is completely different to anything we've seen before. So what comes out of Imagination? You've got your GPUs. We know also that you're strong in RISC-V. We talked about that last time we came to visit you. So how do those two technologies sort of come together, and how are they being deployed then by the automotive industry?
So what we've done initially with the RISC-V is we actually now have a RISC-V on our GPUs. So we have our firmware processor is RISC-V. So we're using it ourselves, and this is the first time we're bringing it into market through the GPU. We have CPU products. Initially we've got real-time deterministic CPUs that are really useful helper cores. And as you see that being dispersed across the automotive space to meet those requirements, helper cores are really useful being. So that's RISC RISC-V there is a real focus. And then going forward in time, we'll continue to grow our CPU families to address a wider range of markets, but always off the back of the knowledge that we built from GPU, we're able to very quickly apply that to our CPUs because we've been supporting automotive products for 20 plus years. So it's a good heritage to build on for our CPUs.
Now, when we talk about data centers, the first thing we think of is these enormous buildings, humming noise in the background, and an enormous amount of compute. Mm-hmm. If we go to somebody like Amazon Web Services or Azure, we can obviously rent that computing power, but obviously one of the other things they're also offering in larger quantities are GPUs, servers of GPUs. Yeah. So what's the data center community and those customers looking for from you in order to sort of offer new services to their end clients? What's going on?
Yeah, so they're looking at how a different way of doing it, because they've got kind of like a footprint of power and space that they can use, is how do they offer the variety? And as we see cloud gaming really taking some traction, growing over the next few years, is how do they do that in an efficient way, and how do they do that in a way that they can offer different services? So you've got your casual gamer who probably could use a smaller amount of GPU functionality than maybe one of your premium, real serious gamers. So with our GPUs, working with customers and how they can do that, using some of the similar technologies we've used in automotive into the data center, so that they can scale with the needs and scale and give flexibility. So that means their services can be more cost effective and easier to implement.
Super. Well, thank you ever so much for the great update. It's really interesting to see what's been happening in the last 12 months since we last saw you, and we wish you a great success with the rest of the day.
Great, thank you very much for coming to talk to us.
Hi Shreyas, it's lovely to see you again. We chatted last year at Embedded World. We're back at the Imagination stand at Embedded World 2023, and I hear some great news regarding RISC-V, that you're representing Imagination Technologies as part of the RISC-V International. Tell us what you are doing and what impact that has on the development of RISC-V as a technology.
Sure. Good to meet you again at Embedded World this year as well. So Imagination is committed to RISC-V. We announced our first product. We launched our first product mid of last year, and to extend our ongoing commitment to RISC-V, Imagination decided to extend our leadership role within RISC-V by going up to premium membership in the RISC-V International. So with that, I joined the board of directors of RISC-V International, and a number of my colleagues joined the various working committees within RISC-V International. And together we are trying to lead and work with the community to drive the success around RISC-V.
So what's been going on as well in Imagination in terms of RISC-V? What sort of portfolio of IP can you offer your customers?
Sure. So as you can see here, so we have our first product which we launched last year. It's available in an FPGA format. We are running it here on the FPGA. We have our own Codasip Studio, which is shown here, which is working on the RTX 2200, which is our first product. We've already licensed that product to one of our lead customers. It's a data center class device that the lead customer are making, but it's a helper core, a management core within that large SoC that this CPU is getting used to. The next on our product roadmap, we are working towards delivering automotive class ASIL-D class functional safe cores in the latter part of this year, and we'll be announcing more later this year. Next year, we'll be following that up very quickly with application cores running Linux and Android.
Okay.
Android is now a tier 1 architecture. Google has officially announced that. So lots of things are happening around RISC-V. Lots of things are happening at Imagination with RISC-V. So yeah, lots to hear about.
Now, there's a lot of innovation currently going on in automotive. We're talking about software-defined vehicles. For that, we're going to need some really impressive computing performance. What are you seeing happening in the automotive space and the requirements for processing and also GPUs?
Yeah, so in the automotive space, as you rightly said, the needs of the automotive use cases are increasing from a compute point of view. So we have our GPU portfolio that is enabling those use cases from an ADAS to AV kind of range from level 2 to level 5. We are bringing, from a CPU point of view, we are bringing safety island, sort of, little CPUs initially, and as the ecosystem develops, as more adoption of RISC-V happens, we'll be bringing out, high-end application cores in this space as well. So all of that is happening around both RISC-V CPUs and our GPUs.
Now, when a team comes to you and want to make use of this IP to develop their own processors and system on chips, I mean, how deep does the relationship go between you and their team? Is it sort of providing and supporting the IP, or can you really help with integration and full development of a chip?
Yeah, so we've been in the IP business for almost 3 decades now, and we understand this whole process of engaging with a customer on an IP level. So we start very early with potential sort of lead partners. We work with them to define the kind of products that they would need for their next generation devices. So that's an early ideation, validating the requirements for the product. Then as we deliver the product to the customer in an IP format, we deliver it with reference design flows, reference software, reference implementations, and we really, we work with the customer through to their tape out, and then beyond tape out, when they get the chip back, working on porting software, ensuring that the chip is working, and then ultimately delivering that chip to their end customer. So the IP business model is a win-win type of partnership model for us, because we are a license and royalty-based model. We rely on our customers getting successful, and we are literally with them through the whole journey.
That's great. Well, thanks ever so much for the update here. It's great to hear that you're so committed and involved in RISC-V. It's a really exciting project, and something we're seeing a lot of development of, and we look forward to seeing what comes next.
Yeah, thank you very much. Thank you for the talk today.
Hi Brian, it's lovely to be back at the NXP stand. It's Embedded World 2023, and every time I meet you, you've got something new to share. So
that's true.
What's going on? As we always know, we had you on the Engineering Insights show talking about automotive and all the development and advancements in automotive to make a sort of software-defined car. What chips are you bringing out now, and what difference are they going to make?
Yeah, it's becoming a habit. We've been enjoying. Met with you. So we talked about the brain of the EV, we talked to the brain of the motor, electric motor, and now we're talking about the brain of the complete vehicle for vehicle computers and high performance safety. So what we did is launched our S32 G3 family yesterday here at the show, which takes our S32 G family overall to a much higher level. So we have the S32 G2 series and now the new S32 G3 series, which has 2.5 times the performance, the memory, the networking, and really takes it to the next level that's required for software-defined vehicles and more of these high-performance ADAS and autonomous vehicles for safety processing. So that's what we announced here at the show yesterday. It's in production and actually in some vehicles today. Yeah.
So give us a bit of an idea then, what's actually inside the chip? How many cores do we have? What sort of memory? What sort of connectivity in order to make all this possible?
Yeah, great question. So this is actually a combination of safe compute, networking, a lot of networking interfaces, networking acceleration, and it's built on a foundation of functional safety. It supports up to ASIL-D systems, and it has embedded hardware security engines, so it's bringing all those together. Right. Now, if I talk about the cores themselves, there's actually 30 cores in this device. It's pretty amazing. Actually, this is the device. It's a 19mm package. So incredible. All of it's in that little package. Yeah. There's 21 ARM cores. Of those 30 cores, 21 of those are ARM cores. Yeah. And there's a combination of real-time cores, Cortex-M, and application cores, Cortex-A. Yeah. So this part is fairly unique because what it does, it's not, there's parts that are microcontrollers, there's parts that are application processors. This brings all of that together, so it's a combination of that with network and acceleration. So now I can accelerate 16 CAN FD channels. I have 20 on my chip, 16 can be accelerated. I have 4 gigabit Ethernet ports, and 3 of those now with this part are 2.5 gigabits per second. Okay. I can accelerate those, I can manage the data, I can manage all those packets and do it very efficiently. So all those cores, even though I have all those cores, they don't have to deal with all the busy work with the data. They can be handled by the network accelerator. So that's really what's key about this part, is lots of real-time application processors plus networking, plus accelerators, and all built on functional safety and security.
Now, when we've spoken in the past, and when I've also talked about with other people on my show about the automotive, what we're seeing is the architecture of the car is changing.
Yes, definitely.
And there's sort of two competing ideas. Either we have a domain controller where we have processors handling different domains of the vehicle, like braking, steering, bodywork, chassis, or then we have the zonal process. We have a really powerful processor in the middle, and sort of functionality could even be distributed across several ECUs.
Yes.
Now, is this device targeting one of those, or can it support both architectures?
Yeah, that's an interesting thing. There's actually, I don't know if they're necessarily competing, sometimes it's evolutionary, and sometimes they work together, because I think this is a process. It depends on the OEMs. Every OEM's a little bit different, and if you look at the evolution of this, or revolution to zonal, sometimes it actually happens in steps. Sometimes people can move faster directly to zonal. So for us, we're agnostic because we design these parts to be able to support both those types of architectures with the compute, with the networking. But what's really important, it's the common denominator of that is consolidation, integration, and cross-domain integration of multiple functions sometimes. That requires a new type of SoC or a new type of processor, and that includes isolation. So I can have multiple tasks. Like today, it's isolated by boxes, right? ECU and ECU, and they're connected by wires. What our chips do, and like we talked about last year with the Z&E, is that they're isolated inside the chip, isolated in hardware. So we're doing that today. That's really important. So for our perspective, we can support domain or zonal, or there's combinations, hybrid. I mean, some of it are starting with body, where they're putting body in zones or electrification zones, and then the whole vehicle may be zonal over the next few years. So it doesn't always happen at once in those cases. So we're pretty open into it. It's definitely a hot area, and that's why these chips are really popular, because the G, so where does this fit in? So the G2 and G3 fit in that central computer or the gateway functionality that are bringing the whole vehicle together, all the data. Not only the secure networking within the vehicle, but secure connectivity to the cloud, working through the telematics unit. So it's the heart of all the data flow, secure data flow through the vehicle. Because it has all the application processor, it can now do services. And we're actually showing this with the G3 here, is we can actually put services on top that can be deployed through Kubernetes data center type technology within the car. So it's really the heart of all of these, whether it's a domain architecture where it's the gateway and the master brain working with domains, or it's the vehicle computer that's doing the overall vehicle strategy and working with zones to do the actuation and sensing. We do both, so it doesn't matter.
Now, one of the interesting things we're seeing in the automotive space, as we've discussed before, is the software-defined vehicle, and the key element, and we were talking about this, about the electric motor platform as well. When I buy my car, I'm going to have the worst performance electric traction than I'll ever have over its lifetime, because the software will be updated. But I think one of the challenges we have in the automotive industry, typically when the ECU is finished, we ship it and we don't touch the software again. And you just mentioned cloud, Kubernetes. What are we learning from cloud and sort of containers and software updates and live updates on systems, and how's that moving into automotive?
And this is a huge area. We could do a whole episode just on this. So yeah, there's multiple angles for it. Let me talk to at least a couple of those. So there's within the vehicle, so we're talking about the Kubernetes, and having an infrastructure so you abstract the hardware and software. Basically, you're just layering these things on, and they're isolated, they're containers. That's one angle to it. There's also the over-the-air updates of discrete functions that are not containers necessarily. It could be complete virtual machines, it could be the whole system, it could be a core in the real-time section. That's an over-the-air update process, and we support that too. Typically with partners, we have multiple partners that allow us to do that. So there's that whole process. Now what's the key thing with OTA, I think you referred to, is that a lot of times these ECUs are black boxes. Typically they're very I would say limited in capability, limited in security. Maybe they only have symmetric cryptos. They don't have asymmetric cryptos. They don't support digital certificates and public key infrastructure. So that's the challenge today with today's vehicles, is that they're closed boxes. They're not updatable. They're never intended to be updatable. And so what the SDV is doing is actually making those software functions with common security, whether it's the G, the Z, the E, or the K. From an XP perspective, we can do end-to-end vehicle over-the-air updates. And we have one of our partners, Ubiquiti, has a suitcase, a car and a vehicle that has all of them in a box doing system-wide upgrades. It just shows that once you have parts like what the S32 types of parts that have, asymmetric crypto, support public, even doing post-quantum crypto today, we're showing that, but have a common security architecture where whether I'm a supercomputer in the car or I'm a small little microcontroller in the car controlling lighting, all of those have security that can enable end-to-end security and over-the-air updates. That's critical because you want to be on public key infrastructure, just like everything else in the world today with certificates. Yeah. Gives you a lot of flexibility, a high level of security. So the future is going to be over-the-air updates throughout the system, vehicle-wide over-the-air updates, and then like this, the Kubernetes containerization types of deployment of services. And where the cloud comes in, the cloud is critical because now the OEMs in the industry are using the cloud to do virtual development. So I could do all my software development on our chip in the cloud, not even having to be on hardware, develop the software, test it out, do integration, and then deploy it through over-the-air updates to the vehicle and the chip. Yeah. I know SOAFEE and ARM and all these companies are working on this environmental parity so that they can run software on S32G or these types of parts in the future in the cloud and then deploy it to the vehicle. And that's that whole CI/CD, continuous improvement, continuous deployment, and the ability to have this whole DevOps flow for SDV because you want to deploy it through the life of the vehicle, which is over a decade plus. Yeah. So there's a lot of complex, like I said, we could talk about this for a whole episode.
Exactly, we were talking to Robert Day at ARM about SOAFEE. So what's NXP's role in that project, and how are you going to contribute to that? How's it going to contribute to you?
Yeah, definitely. So that's one of the important initiatives that are going on. I mean, NXP is really heavily involved. I mean, we're a thought leader involved heavily in SDV. SOAFEE is a key part of it, also Eclipse Foundation and others. For SOAFEE, we've heavily involved there. I think we're showing these kind of capabilities, working with SOAFEE, with AWS, with ARM, and all these types of members to bring, because it takes a village, right? It's an ecosystem to bring it all together, and our platforms are really attractive to do that, to start to showcase how can I deploy these into Kubernetes or containers, or how do I extend this into the real time? Yeah. So we have the S32Z and E, as you know, and the Green Box 3, and how that gets extended in. So I think we're going to be a key partner in that with the hardware platforms and working with our cloud and other partners in the ecosystem to really make SDV reality and to streamline the whole process. I think the key is going to be how do we standardize some of these? They're non-differentiating per se, right? Is how we make the infrastructure work on top of hardware that under the covers is really optimized for doing all these things that have to happen. Yeah. That's the differentiating part, the silicon, the software, the ecosystem can provide the non-differentiated part, and then the innovation on the top level, the software-defined vehicle now explodes, right? So you need that layer, which is what's important that SOAFEE is helping to standardize to make that happen. So.
Well, every time I talk to you, Brian, I keep thinking I need to put off buying a new car because I want to make sure there's NXP inside.
There you go, appreciate that.
Thank you ever so much for the update, and wish you all the success with this new product, and hopefully we'll have you back on the show shortly.
Definitely.
To
our next innovation.
Yeah.
And thanks for stopping by again.
So hello Clara, it's lovely to meet you here at the NXP stand. We've seen a lot of new automotive chips and a lot of new automotive technology coming out of NXP, and here you've got some new exciting stuff around the battery management system, which is essential for these electric vehicles. So tell us what's going on.
Yeah, indeed, Stuart, thank you very much. It's a pleasure to talk to you today. So here we have the high voltage battery management system that is demonstrated, and it consists of all the great goodies from NXP. So we have the cell monitoring units with the analog front end that is able to very accurately and precisely measure the state of health of the battery, to measure the state of charge of the battery so that we can do optimal load balancing in the battery. We also have the battery management unit that is able to get all that information and do the basic calculations for the battery management. The battery junction box, which is making sure that the battery is safe. And finally, we have the gold box, which is our internal routing mechanism that is using all of the information from the car and send it to the cloud. And in the cloud, we will have a partnership with Elektor Vehicles, which is a company that we work together with to make sure that we optimize the battery. But this is the question we might have is, why is battery management so important, right?
So,
of course. In electric vehicles, the battery is the most expensive part, and if you drive an electric car, you start thinking, people start to get range anxiety, they get worried, when can I charge, when can I discharge? So the optimal use of the battery, the more efficient we can use the battery, the easier the life is for the electric vehicle customers. But actually it's the more efficient use of the energy, and energy usage and optimizing energy usage is a very important topic.
Now, as you said, obviously the electric battery is our energy source for the vehicle.
Yes.
Why are we using the cloud, and what is the cloud offering us in terms of extending the life of the battery?
Yes.
Why don't we just do all of that stuff in the vehicle itself?
In the vehicle. So the batteries are based on chemistry, and chemistry is still something that we cannot predict to the last moment. So the computation that we require to be able to predict what's happening with the battery, to be able to understand when is degradation, when are we getting into a danger zone, those computations, they require quite a lot. So we cannot pack all of this computation into the car. So the cloud is basically our extended intelligence, it's our extended computation power that we can get. So what we have implemented with our partner electric vehicles has implemented in the cloud is a digital twin model of the battery. And this digital twin model is based on AI, but it's also based on the physical chemistry model of the battery. So it's combining the best of what we know about models and what we can get from AI. Of course, all of these computations take some time, and the digital twin is running at real time and is getting the information from every car, is getting the information from different parts, different cars, different models. So it's really optimizing and getting all the best knowledge of that. In the car, you have a more simple model that is running at real time, but it's based on the cloud. So if the cloud updates the model with new knowledge, with new use cases, with new corner cases, it's able to transfer that information to the car back, and then the car can always be working at the optimal moments or at the optimal according to the model in the cloud. So that's the combination, and that's, I think, what makes it very powerful. It's not everything in the cloud, it's not everything in the edge. It's the working together of the cloud and the edge, taking the best of the two worlds.
Now we know that the batteries in the car are obviously very expensive, and they're not used completely to the end of their life in an electric vehicle, are they? So there's a lot of discussion about second life. Can I reuse those batteries, recycle them essentially in new applications? Does having that data in the cloud and this sort of system make that second use role easier?
Yeah, it will definitely help us, because when you take a battery and you want to give it a second use, which is very common now, that you can put it in racks for an industry or for your home to be able to store the energy, renewable energy generated from your solar panels, for example. You want to know, this battery is a second life, but what kind of first life did it have? Yeah. Because the first life sometimes determines actually the second life. And having a way of storing that in a secure way and really having all that information helps you a lot. It also helps you to basically being able to negotiate the price of your second life battery. So if my battery was treated very nicely in the car, very smooth and gentle, then it will have much more value for the second life. And we are also working on some new concepts, like for example the battery passport, where you make sure that you are storing that information securely, and that basically you can, when you sell your battery, the end user has a confirmation of, okay, this battery, this is the use it has been given. And depending on the type of the second life, that might be acceptable or not, and you can basically range your batteries for your for the second use.
It's interesting you bring up the point about the battery passport. Is that an initiative that's being driven at government level, or where does that come from?
It's a concept that we, of course, want to have, because I think it's important to ensure the part. And at this moment, there are several initiatives happening. Of course, for the government, this is something that needs to be standardized. Yeah. And there are many technologies that we could be using for this battery passport. And to the best of my knowledge, right now, there is nothing. Let's say, okay, this is how we are going to do it yet.
So a work in progress.
It's work in progress. Yeah.
Now, one of the other things we see in the electric vehicle space is obviously the batteries. If we can get the voltages up higher, we have less current flowing through copper, and then the cables are smaller, and that aspect of it. So
there will be less heating. You will be able to fast charge. So going up in the voltage is definitely a trend. So right now we have a reference design, high voltage reference design for 400 volts. We have all the hardware. We have the basic software. We even have some safety libraries, so really give our customers a head start with the safety libraries that are available. We are working towards the 800 volt, and of course, if we look at the future, we see the 1200 volt also coming up. So it's definitely something we are looking into and investigating. you see that there are also different models there, different way of working with parallel serial working of the different batteries online. And yeah, all very interesting future topics.
Super. Well, thank you ever so much for all of the insights in the development of the power system behind the electric vehicles, and we'll be looking to see how that develops over the next few shows.
Great. Thank you very much. It was a pleasure talking to you.
So hello there, Eddie. It's lovely to meet you here at the ADLINK stand here at Embedded World 2023. Autonomous vehicles are a very exciting topic at the minute, and we're looking at how their algorithms are being developed. How is ADLINK helping the automotive industry bring autonomous vehicles to life?
Yeah, of course. So our main target customer is for autonomous vehicle, like robotaxi, autonomous truck. So the system needs to navigate through the complex environment and do AI decision making in real time. So ADLINK provides a comprehensive solutions, provide powerful hardware and also redundancy. Okay, so our customer, they will have two stages. Proof of concept stage is here, and mass production stage is there. So first, I'll start with the proof of concept stage. So in this stage, customers still developing and fine-tuning their algorithm. So they're not very sure what kind of hardware capabilities they required. So usually they'll buy the off-the-shelf products and connect them together, so it's fast and flexible. So here you see the products here. So it's like the eyes of the vehicle, and it's like the brains of the vehicle. So for the eyes of the vehicle, you need to perceive the environment with different sensors. So here is a 3D LiDAR. You can scan the surroundings, and here is the GMS2 cameras. Usually you have 8 to 12 GMS2 cameras in the surrounding views. GMS2 camera has high definition raw data and can transmit over 15 meters without degradation and also power over coax. One of very important is the sensor fusion.
Right.
Why do we need sensor fusion? Because different sensors have its strength and weakness. For example, camera is very good at object detection and peoples, but during bad weather, so dark, it doesn't work that well. But for the LiDARs, it can see very accurately for the people and distance even in darkness. So combine those strengths together, we can understand the civil environment very accurately. So this one is based on the NVIDIA Jetson Orin and GMSO cameras with forward cable connectors. So after we sensing the environment, we are getting all this information into our brain. So our brain needs to do a lot of calculation in a very short time, like localization, perception, prediction, planning, and control. So we have very strong Intel CPUs and also NVIDIA GPUs and CAN bus. So we also do customers also interested in the simulation before they do real deployment, because they want to verify their algorithm, make sure it's robust and accurate enough before deployment to save cost. So we also have these demos working with AutoAware Foundation to do the digital twins to verify their algorithm in our hardware, which runs very smoothly. So one of the customers, like in the POC stage, they buy 7 this kind of hardware in their truck. Yeah, it's a very huge one.
Yeah.
But they got their algorithm very good and then raise more money to move to the next step, commercialization.
So we're starting here with a very powerful, let's say, over-engineered solution in order to learn and train the algorithms, get the inferencing working, and look at the challenges involved in making autonomous vehicles happen.
Exactly, yes.
So once we've finished developing our algorithms, it's time to commercialize that solution and reduce it down to the electronics and the processors that we really need. How does that process happen at ADLINK, and what do you do to move it into the final, from prototype to production?
Okay, for sure. So some of the top unicorns in our customers, they're already going to the commercialization stage. So they want to consolidate so many IPCs into just one, the integrated system. So we have this powerful integrated system, include CPU, GPU, and safety MCU all together. So CPU, we use Intel 7 Rapids. It's a server grade, very powerful. NVIDIA GPU, we use Jetson Orin and RTX series. For safety MCU, we use Infineon TC397 series.
Okay.
So for the main purpose of safety MCU is monitor the system's health. So when the main system fails, it can take over and pull the car into a safety place nearby. Yeah. So another thing is, because this system has very high power consumption, very powerful, So we also have our in-house DC-DC power design. Our power also have redundancy. One for the main power system, redundant power for the safety MCU. And this is from different power sources to ensure if one fails, another one still works. And because this one has very high power consumption, traditional fan and fenders just doesn't work for the thermal dissipation. So we'll also incorporate the liquid cooling solution. Yeah. We'll get the coolant from the car, from the vehicle. We'll go through the inlet coolant and go through all the heat sources like CPU, GPUs, and going out. So we have very quick thermal dissipation. And because the vehicle is running on the road, so we need to have the anti-shock and vibration capabilities.
Okay.
For example, traditionally we'll have the memory. It's a memory RDIN on it. But when the car is running, the RDIN could like shake and has some issues. So we also implement the memory onboard design to ensure it runs smoothly. Another key part is for the automotive connector. We have special automotive connector which is very rugged, like M12 for the Ethernet and LiDAR. We also have the CMC, Molex CMC connectors, and also Fagua cable. So which is all very rugged. When you plug in, it's very hard to put it out.
Good.
Yeah. Another special capability is we have the time synchronization capabilities. As I mentioned, sensor fusion has so many sensors, so we need to ensure that timestamp is aligned. So usually we'll have the GPS from internal source, and then we'll implement the FPGA to do the hardware trigger all the sensors to have the same timestamp. So here's our customization stage for our customer. Integrate 5 to 7 into one integrated powerful systems. And at the end of this year, we'll have the standard product for these special strong systems. Yeah.
Fantastic. Well, thank you, Eddie, for taking us through the development process for autonomous vehicles. It's really exciting to see how it's shaping up and the demonstrations you've shown us today at the ADLINK stand.
Okay, thank you very much.
So hello Giancarlo, it's lovely to meet you in person. We had you on the Engineering Insights show. Today I'm at the Eurotech stand chatting to you at Embedded World 2023, and I'd like to understand a little bit more about the fantastic demo you've brought with you. What are you showing us?
Thank you, Stuart, for having me. I'm here to give you a representation, a simple explanation of what our technology is about. Eurotech is a leading provider of edge devices. In this demonstration, we show how simple it is to deploy an edge device and how this can control the functionality, the operation of an asset in the field. For example, in this case, we have a camera. A camera is detecting the pose of your hand, and this information is sent up to the cloud where a digital twin that we can recreate with our cloud remote device management platform can control a robot arm in the field. It's very simple. It doesn't require a single line of code to be programmed and deployed. It's secure because all the solution from the asset up to the cloud is cybersecurity certified. We have a certification IEC 62443. It's international standard for cybersecurity. It's also agnostic because it allows our customers to integrate this solution from the edge up to the cloud with any cloud provider they already use. Whether it's AWS or Azure, which are the most popular, we can integrate our solution with that.
So this is an interesting aspect, isn't it? So we've got the OT side and the IT side in production environments, and up until now security hasn't really been sort of implemented all the way through, let's say. So,
that's correct.
So what are the challenges for industrial systems in implementing security, and why is this so easy?
That's a good point. Actually, cybersecurity is often a misunderstood type of concept, right? So people associate it to only parts of the system, whether it's a VPN or a password or a key to share. That is the misunderstanding about security. Actually, cybersecurity is a holistic concept. It needs to take the system from the root, right, starting from the hardware, with anti-tampering capabilities. You know, this device has anti-tamper features that protects the hardware from being tampered with, right? So being attacked. but then it needs to project from the root of trust, right? So from storing security secrets inside the hardware, it needs to communicate securely to the cloud. As you said, all the steps from the hardware to the key management to the provisioning going up to the cloud needs to be securely certified. So there are cybersecure claims and there are certifications, and that's where the difference is. Third parties, certification bodies, accredited labs have demonstrated that our solutions are at the edge of the security of today's knowledge. Yeah. Right? And also these systems are not, like cybersecurity is not a concept that is just true and frozen in time. It needs upgrades, it needs to catch up with the new security threats, so our system is continuously monitored for security threats and upgraded when it's required.
Now you said that it's cloud agnostic, it's able obviously to link up to Azure and AWS. Yep. Does Eurotech also offer a cloud system or cloud service to match up with the hardware that you provide?
Our focus is on the edge. We like to say that we are edge-centric because we provide all the tools, all the elements, hardware and software, to make the edge work in a secure way. When it comes to the cloud, we like to see ourselves as partners of the major cloud providers because our competence, our expertise is with the managing the assets and managing the edge. So I don't see an overlap, I see absolutely complete space for collaboration there. We provide optional device management platform that can be integrated with the famous data platforms from AWS and Azure, and we do not overlap in offering the data platform.
Well, that's great. I said, as a fascinating topic, security is a big theme here at Embedded Worlds, and it's fantastic to see how you're implementing it and what it is that you're offering to those customers in the industrial space. So thank you very much.
Thank you, Stuart. Thank you for your time.
We also got to see the Dynacore water-cooled high-performance edge computing system that we covered in Engineering Insights Show 15 from Eurotech. In Engineering Insights Show 17, I spoke to Rodrigo Mesquita from Nexperia Energy Harvesting Solutions. At the show, I managed to capture their solar energy harvesting demo based upon the NEH2000BY, helping to show this technology in action.
So Vanja, it's lovely to see you here at Embedded World 2023 again. You're here again with the Qoitech team, showing us how we can make sure sort of like the batteries that power our applications are really matched to them perfectly to get the best life. So what are you showing us show today in terms of measurement technology?
So what we are doing here is really trying to give the developers the possibility to really see what their application and devices are doing from the energy perspective in real time. Full length, you can measure how long your computer really allows, and to when you have understood really what is draining the energy, then find the perfect the energy source for it, whether that be the battery or the energy harvesting solution. The importance here is to really see that you are taking out that capacity that you really need, and that you're looking into from the cost perspective, for example, that you're picking the right size of the battery, not only in capacity, but maybe form factor as well. And all these challenges are something that our customers have, and they have really needed something to see how this can be, how can you do this in an optimal way. And I think recently we have got a lot of feedback that this wasn't really possible before. You separated this application profiling and the battery, very much so, but now today this is what we can provide. You can actually do this with one and the same tool.
Now the Qoitech solution is sort of, I'd say it's in two parts. You've got the software as part of it and the hardware. And recently you've also expanded the hardware option. So just run us through what hardware do you have and what's the difference between the two boxes essentially that you're providing to your customers?
Yeah, we call them the magic black boxes, and they really are magic from the perspective they are all-in-one boxes for the energy optimization. They are power supplies, but they are also power profiles and power analyzers. And they can be absolutely extended to be also battery profilers, energy harvesting profilers, and emulators. And the difference is really simple. The first project that we had out on the market, Otii Ace Pro, it's the one that is the up to 5 volts, so it's very much focused on the sensors and the IoT space, whereas the new one that came out recently, Otii Ace Pro, is the one that is up to 25 volts. And absolutely better technical specification. We call it a little bit of a big brother to Otii Ace. So the people who really want to go full-blown into the sampling rate and floating grounding, so you can do serial setups of these measurements, this is all now available. So it's a little bit more of an advanced feature that we have provided. And we have seen the reason for this because our customers are going from really small, they have a portfolio of really small sensors up to really large things. It can be an e-bike or something like that, and they really wanted to make sure that they're using always the same tool in their development, so they have the same language around energy optimization.
Now the software environment, I've seen it in the past, it's very clean, very easy to use and access all the features, but you've done quite a lot of work in the past months to sort of update it. What sort of new features are you adding into that, and what benefits does that bring into the customer base?
So it's really important for us to make sure that the customers are still finding their way around the UI, but we have improved the UI dramatically from the perspective of customer having to look into what is the most important thing, which is the graphs and the analytics of it, and connecting that to the software, understanding what is really happening, what is draining the battery, or what is draining the energy. But the behind of all that was actually a big push to make sure that we got further on our robustness part, because our customers really use our tools in field applications and really running long measurements, and we really wanted to secure that that can be further extended. And in addition to that, we really wanted to make sure that the software is modular, so we can help the customer choose and pick how they want to use this tool, because you can use it either at the embedded engineer stable, or you can use the test verification in the continuous integration, or as a battery simulator. So there's so many different options within the same space that then you can easily accommodate in your development team.
Now, one of the key things that we see around test and measurement is also automation. We want to be able to, like you said, run tests over a long period of time, maybe respond to anything and maybe flag an error or a change, yes, or even implement it as part of a test ATE, yes, during production. What's it look like for you on the automation side and programmability?
That is a big deal for us. We have a toolbox, a software toolbox called Otii Automation Toolbox. It's all about scripting, so it allows scripting in multiple languages. Python is one of the big ones. C# is there as well. We have TCP servers, so you can pretty much very easily do whatever you want to. And this has been one of the key things that we wanted to really make sure that it's really easy for developers. They should not spend a lot of time of creating these automation tests. They should be using them. This should be something that saves them time, yeah, and the effort. So this is one of the bigger toolbox that we are selling today.
Super. Well, thank you for giving us the update on the Otii Ace. It's a new product which I haven't had a chance to see before, mm-hmm, and the software updates as well sound exceptionally exciting. So thanks very much for chatting to us today.
Yeah, thank you very much.
So hi Sascha, great to see you here at the stand. Embedded World 2023, we're with you at Cloudflight I/O. One of the most important things about a product, especially for consumers, is how that product looks and how easy it is to control and set up. And you're a specialist in human-machine interfaces, HMIs. Tell us about how you support customers getting that perfect look.
I'd love to. So first, thank you for visiting us here. What you see here is a quite good example on what we can do for our customers in end-to-end digitalization. Starting with a human-machine interface, we provide the HMI design, can do the implementation, development for them on the front end, but also in the back end, talking about fleet management or IoT solutions, like predictive maintenance and so on.
So there's a broad spectrum there. When it comes to something like this is a coffee machine that's obviously not really designed for the home. This is more of an industrial type coffee machine. Yeah. What's implemented on the back end, and how do you help with the development of the back end in order, you can do predictive maintenance and monitoring?
In the back end, we do, for example, here for Melita, the Melita Insights, which is their portal where their end customers can control recipes, can monitor them, can also control the advertisements, what they show on the displays. So yeah, everything which is important for an OEM can be controlled in this
space, yeah. So there's also lots of different screens, lots of touchscreen technologies, lots of IoT solutions. Are you able to help your customers with any of those, or do you specialize in certain types of specialize with certain hardware providers?
No, we're in terms of hardware providers, we are quite agnostic. It's also when we're talking about cloud, we can go with each and all cloud providers. So we provide the service, whatever the customer needs. Most time they have already selected a hardware, and we help them to make their hardware to have more performance on their hardware.
Yeah.
When we consider clean rooms, or we are in a food industry where we don't want to have the pollution or thing, there we have the holographic touch, what we develop with a hardware partner, where you can, without touching the device, can enter, can make selections. It might be interesting for elevator control or door access systems, ATMs.
And what sort of application spaces or market segments are you helping people? Obviously this is a coffee machine, more sort of industrial coffee machine solution, but what other areas can you help in?
We are on the one hand in the field of manufacturing, talking about machines and devices. We are in healthcare, we are in space where we process petabyte of data, of satellite data. We are in transport logistics, we do e-commerce, so there are
a really broad range
of industries, and other industries are emerging as well.
Super. Well, thank you ever so much for taking the time to show us the innovation in HMIs, and yeah, we look forward to catching up with some more solutions at the next show.
Yeah, great. Yeah.
So, hi Jenny, it's lovely to meet you here at the Nuvoton stand at Embedded World 2023. Now, you're demonstrating here some interesting time-of-flight cameras. Yes. How are they going to be used in the automotive space?
Okay. Thanks everyone. I'm Jenny. That shows this demonstration. The first one, this is using our 3D ToF technology sensor in the automotive parts. And how does it work? We have this kind of detection by our 3D ToF sensor. Then actually customers, we can detect the driver's status, whether it's sleeping or not, or eye is open or closed, or even you have the different direction of your eye, like switching from left to right. We can use this kind of a 3D ToF sensor to impress this kind of situation, and to try to alarm that driver is not sleeping, or even they cannot use the phone, or even the dangerous things that happens when you're trying to drive. Yes.
So the camera itself is a time-of-flight camera. We're collecting lots of 3D data in that short space. Yes. And it's able as well to detect other things like the use of a mobile phone, or even if the person's smoking. Is that correct?
Yes, that's correct. So not only the status about the driver itself, but also when you're using the mobile phone, or even the one that you're smoking. And also I think there's a one that without some unsafety things, then those behavior can be detected by our 3D ToF sensor.
So Jenny, a big application, something that's popular, is object detection.
Yes.
what are you offering here at Nuvoton in order to help customers who want to do object detection with cameras and processors?
Okay, so let's introduce our latest MA35D1, the latest microprocessor. This microprocessor, we have like dual core A35 core inside and also a real-time M4. And of course we have like the camera, so we can have the CMOS interface to connect with the camera, then can detect the how many object or even the human being, how many human being count inside this product. And of course that we can run in the TensorFlow Lite, so you can have the very good well training of the big data, and so at the here you can see the result about the people count and also the object detection of the result from our screen or monitor or even LCD panels.
So we've got two very large, powerful processors there, and then we have the M4 core for real-time performance. How do those two processors communicate with each other and share information successfully?
Okay, that's a really good question. The first one is that A35 that runs on the Linux-based Linux OS. And the one that M4 we do the real-time job, and M4 is basically runs on the RTOS. So we like the communication is like the mailbox interface to exchange the data and the transmission between each other. So that's how they communicate with each other.
Super. Well, thank you for guiding us through the demonstrations here on the stand at Embedded World, and we're looking forward to seeing what else comes out of Nuvoton in the coming year.
Yeah. Thank you.
So hi Brett, it's lovely to meet you here at the Codasip stand at Embedded World 2023. Let's start by explaining a little bit about what Codasip does.
Great, thanks Stuart, we appreciate it. Codasip's a company that was founded in Europe. We're headquartered in Munich. Our R&D resources are entirely in Europe, and we're focused on the RISC-V and RISC-V ecosystem. What we do is we provide RISC-V IP to our customers, as well as tools that help them enhance and customize RISC-V to improve their differentiation in the market.
Now that's one of the most exciting things I think about RISC-V is that customization capability. If we look at the ISA, there's that lovely gap in there where we can put our own instructions, but it's not an easy process, is it? Tell us how do you help people do that and get it right?
Sure. Traditionally, a number of the microprocessors that have been out in the market only allow you to use their instruction set architecture or their ISA as is. RISC-V, as you mentioned, is an open standard, and while there are open source aspects to it, the open standard allows people to go off and build custom instructions or customize their processor to do things that are unique for their software workload. The challenge with it is that if I've customized my hardware, I then have to have an entire software tool chain that supports that customization. So what we do at Codasip is we provide a tool called Codasip Studio that allows you to quickly and easily modify or even build your own RISC-V from the ground up. And then as the output of the tool is not only the hardware design kit, which is your Verilog, UVM environment, and vectors and things for verification, it's also the entire software chain. So we give you the compiler, a custom debugger, custom profiler, and all the tools that you'll need so that your software now can use those custom instructions automatically.
So that means that if I'm starting to develop some new assembly instructions in the instruction set, am I then able just to write C code which will understand when to use those instructions, or are we just talking about inline assembler support?
It's a great question. So automatically our compiler will pick up your new custom instructions. You can, of course, at any time write assembly inline, but that's a little bit old school, but sometimes you need to for performance reasons. But in general, the compiler will pick up these automatic custom instructions.
So take us a little bit through the process of designing custom instructions. There might be, I don't know, let's say a multiply and accumulate of say like 8-bit data or something that we really want to accelerate. What's the process for your customers as they're using the studio to firstly develop it and then make sure that instruction does what it's supposed to do?
Yeah, that's a great question. So what happens is you might be using our L31 processor, which was an award-winning Embedded World one last year, and the first thing you would do is you'd profile your code. So what we want to know is how does your software workload work on the processor? And so with your software workload, we'll run through it, and we might find there's a hotspot in there. And the hotspot, the engineer might determine, wow, if I just had an 8-bit multiply accumulate, I could go ahead and eliminate a bunch of code from my source. So what you can do is you can go off and you can model first at an instruction accurate level. You can model that instruction, and you can do some architectural exploration to find out, does it really solve my problem? And what's the performance improvement, or what's the reduction in the number of lines of code? Over time, what you'll do then, once you've decided on what your custom instruction looks like, you'll refine that down to a cycle accurate level. And the cycle accurate is ultimately what you're going to build in RTL. And so the tool allows you to do all these things, create all the compilers along the way, do the exploration, and then ultimately refine it down to something that will build your very own RISC-V RTL processor.
Now RISC-V, for people who, many people have heard of the term and understand the buzz behind it, but I mean, what sort of range of different processors are available from someone like yourself that are RISC-V based? What are the options? How are they different to each other?
Sure, it's a great question. So one of the things that we start with is the embedded cores. We've got a full lineup of embedded cores that you could use today as is, or you can customize them to go forward. We also have mid-range embedded, and we also have application cores. So it really is anything that runs up to what runs Linux, or an RTOS, or bare metal, however you'd like to do it, in the full range of different processors. Over time, we'll continue to expand that line and target different higher-end markets.
What are the key applications that you're seeing today that are saying, yeah, we see value in RISC-V and also developing our own chip, which is a big commitment. So,
sure.
You know, who's doing that today?
It's across the board. I mean, there's no one application. We've seen things from wireless to camera applications to security applications. And one of the great things about RISC-V, especially if we allow you the ability to customize it, is you can start to figure out what pieces go together. So it might be an AI application that needs some security, or maybe it's automotive that by definition needs security and safety. So really you can do anything with the RISC-V part. I think what you're seeing mostly is people are starting off with the low-end ones as they start to replace other parts that are in their system, because the risk is lower for them. But certainly people want to go the long run, which is the full application level processor.
Super. Well, thanks ever so much for giving us that overview on RISC-V and its configurability. It's a very exciting area that we'll be continuing to talk about in the future.
Great, thanks Stuart, I appreciate it.
Embedded World is more than a trade fair. It's a community of like-minded people sharing ideas, technology and experience. If you've never been, I hope that this collection of interviews provides a feel for the atmosphere and encourages you to visit in the future. For those outside Europe, don't forget that you can participate in Embedded World in Shanghai, China from the 14th to 16th of June this year, and Austin, Texas, the heart of the US computer and software industry, from the 8th to 10th of October 2024. Thanks to all the experts that spoke with me at Embedded World 2023. You've delivered us with some outstanding engineering insights. So that wraps it up for today. Don't forget that if you want to keep abreast of industry trends this year, take a look at News Bites, our monthly 15-minute news roundup. Please like, subscribe to Elektor TV Industry on YouTube, and share our videos on whatever platforms you use. Or drop by the website at elektormagazine.com/EEI to see the topics for future shows. Finally, if you'd like to join me as a guest, write me an email, drop me a tweet, or reach out to me, Stuart Cording, on LinkedIn. Thanks for joining, stay in touch, and don't forget to keep asking your engineering questions.